Yeah. Today's concept is about projectile motion. Projectile motion. What is the meaning of projectile? Okay. So I can give an example that if we throw any object towards the space, okay, how it will go. See, this is an object, I'm throwing it. So it will go and reaches some maximum height and it will fall back to the earth. Correct? This is the path. Like even the bullet fired from the gun and an object dropped from the aeroplane. Okay, so that also comes like this, right? And even you drop a stone from a building. So think that you are standing on a building and you are dropping a stone, so it will also fall like this, right? So these are the projectile motion. So projectile is nothing but, I can say that projectile in the name given to any body which once thrown into space with some initial velocity moves thereafter under the influence of gravity, okay, without being propelled by any external forces. So this is called as a projectile motion. Got it? So projectile motion means, so it doesn't need any external influence once it reaches to the top. See, when you are applying the force at this moment, so with the help of that force, it will reach us to the top. Okay. Then from here, with the help of the gravity, it will come down again. So the path created here, this path we called as a projectile path. Got it? It's a parabolic, we say. So projectile motion, example I can give that object thrown towards space, object thrown towards space falls back with the help of gravity, right? And javelin thrown, javelin thrown by an athlete. Okay, this is also a projectile. The meaning of projectile is, an object that is flight after being flight after being thrown is called projectile. Okay, even you can give an example that cricket ball thrown up, okay, or a stone thrown from the ground to up. So these are the examples for projectile. Okay, so when we throw an object towards the space, here the velocity, okay, velocity takes a two component. One is a horizontal component and one is a vertical component. See here, if I take a projectile motion here, so here the velocity component it is. We are throwing like this, so it will come here. This is what the initial velocity is applied. So at this particular point, if you select, this is an horizontal component and this is an vertical component. And here is how the initial velocity. And we call it as a u cos theta. and the vertical component we call it as a u sine theta. Got it? So horizontal component of velocity, it remains constant throughout its motion. Got it? So during the projectile motion, you should remember that horizontal component, okay, so that u cos theta remains constant, but only the thing vertical component, okay, it is affected by the gravity, okay, it keep varies. Understand? So I can write these 2 points. Horizontal component of velocity remains constant, but the vertical component of velocity is affected by the force of gravity, by the force of gravity. Okay. And here you can notice that at the highest point, okay, when the particle reaches to the highest point, the vertical component of velocity becomes zero. Okay, at highest point. The component of velocity becomes zero. So we call this as I know, from reaching origin to the maximum height. Okay, so this is the maximum height position. So we call it as a time of ascent. And here from maximum point to reaching the ground, we call it as a time of descent. Okay, time of ascent and time of descent together we call it as a time of flight. Okay, how much time is flight in air? So that is called time of flight. Time of ascent is always equal to time of descent here. Yeah. Now let's prove for a trajectory of a projectile. Okay, very important question is now we're learning that trajectory of a projectile is a parabolic. How to prove that? So the question is like that. Show that show that the trajectory means the path created. The trajectory of a projectile is parabola. Trajectory of a projectile is parabola. Yes. So let us draw a projectile. So this is along the x-axis, and this is the y-axis. Here is the displacement. Here is the velocity. Okay. So I'm just taking a projectile here. So it is coming like this. And here at this point, I will resolve into two components. So one is the horizontal u cos theta, and one is the vertical u sine theta. And here is the initial velocity component. Okay. And at this point, the maximum height velocity becomes zero. Okay. And this height we call as a maximum height h. H is the maximum height, and the point from the origin till the end. Okay, the point what it covers, I'll call this point as a B. Okay, so this is, you know, horizontal range we call. The range is nothing but the total distance traveled. Okay, yeah. Let us take, the x as a horizontal distance covered by the body in time t. Okay, so let it be the x as a distance covered horizontally in time t. Therefore, the x becomes, that is a distance, no? So it is horizontal velocity into time taken. So that becomes horizontal velocity is u cos theta into time taken is t. Therefore, the t becomes x divided by u cos theta. Okay? Let's call this as a equation 1. So this is related to the horizontal, okay, component. Now for a vertical motion, okay, observe, I can take the u as a uy, let it be uy, okay, write it as a u sine theta for that vertically. And the acceleration, so it's going against the gravity, hence it is minus g. Okay, therefore the vertical distance covered is vertical distance covered is s is equal to ut plus of at square, use this formula. The s is nothing but the displacement along the vertical, so I'm taking as a y. Therefore y is equal to u. T means, see, u sine theta, uy, let it be the uy. So uy means u sine theta here into t value, we know that x divided by u cos theta plus half into, see, a I can write it as a minus g into t square. So from the equation 1, right, the t square as a x square divided by u square cos square theta. Got it? So now what I'm doing in the next step is I'm cancelling the u, and here sine theta by cos theta becomes tan theta. Okay, so that I can write as a y is equal to x tan theta minus g divided by 2 u square cos square theta into x square. Okay, so I'm taking this as a now ax minus bx square. Just I'm taking this as a constant. So where a is equal to, no, so the constant I took as a tan theta, and I took b as a g by 2u square cos square theta. Right. So here is a function of quadratic equation. Observe. So it resembles the quadratic function, right? So the quadratic function, if you plot the graph in the x and y axis, the trajectory, it gives a parabolic path. Okay, parabolic means that's what you observe. This is the parabolic path. Okay, so for that, We given a mathematical proof for this. Hence, you can write the conclusion that trajectory of a projectile is a parabola. Trajectory of a projectile is parabola. Okay. Now, with the help of this, okay, we can find out the uh, you know the time of flight. Understand? To find time of flight. What is the time of flight? Okay, time of flight is nothing but the time of ascent, okay, plus the time of descent. So this is the time of flight. So let's see for time of ascent only to reach, so to the maximum point. So here at the maximum point, V becomes 0. So this is the time taken, that is time of ascent. Again, from maximum to reach the ground, this is called time of descent. Here at highest point. Vertical component of velocity, it just becomes 0. Okay, I can take it as a V as a 0. Now, therefore, from the equation V is equal to U plus AT. Okay, I'm taking the vertical component of velocity. Just I'll take it as a uy. So here it becomes 0, and this is u sine theta. And when it is traveling vertically up, so a we can take it as a minus g here, minus g t. Okay, that's just I'm taking as a time of ascent here. Got it? For a time of ascent. Therefore, the time of ascent, see, I'll call this as a time of ascent is equal to u sine theta. Therefore, the time of ascent is equal to u sine theta divided by g. Got it? It's just a time of ascent. So how much the time it takes to go up, the same time it takes to fall. Got it? So that is called time of descent. So the time of ascent plus time of descent. So we just call this equation here, substitute that, since time of ascent is equal to time of descent. Okay, therefore, total time of flight T is equal to TA plus TD. So time of ascent is what? U sine theta by G. Even time of descent is also same. Therefore, it becomes 2u sine theta divided by G. Okay, this is the method to find out the time of flight. Next, to find out maximum height. To find maximum height of a projectile. Okay, let's find how much maximum height it reaches once we throw the object. Again, the maximum height means is a vertical component, right? Vertical motion it is. Okay, the vertical at same condition use at highest point. The vertical component of velocity becomes 0. vertical component of velocity is 0. Therefore, the v I can take it as a 0. So use the formula v square minus u square is equal to 2as. Got it? Here, yes, I can take it as a h and v is a 0, right? Minus the vertical component of velocity, uy, it will be there as a u sine theta. So your u sine theta whole square is equal to, and obviously vertically when it's traveling, a becomes minus g, 2 into minus g, and yes, I am taking as a h, maximum height. That is the distance traveled. Okay. So now solve for it. U square sine square theta is equal to, this is minus u square, becomes minus 2gh. Therefore, h becomes, see both the side negative signs will cancel. The maximum height becomes u square sine square theta divided by 2g. The h is u square sine square theta divided by 2g. This is the formula to find out the maximum height. And the next point, in this projectile, how much the horizontal distance it covered. Okay, we call as a horizontal range. To find horizontal range, that is R, capital R. So horizontal range is nothing but it is the horizontal distance traveled by the projectile. Total horizontal distance traveled by the projectile. Okay. So A is given by, see horizontal range. Since it is traveling horizontal, we are calculating. Okay, we have to calculate now horizontal velocity component. Horizontal range is equal to horizontal component of velocity and time of flight. Okay, by the time when it reaches to the end, to the earth back, it completes the time of ascent and time of descent. So horizontal range I am taking as R, and this is u cos theta, and the time of flight we already derived, it is 2u sin theta divided by g. Therefore, R is equal to u square by g, or we can see here u square by g, and have your 2 sin theta into cos theta. So this 2 sin theta into cos theta can be written as sin 2 theta. Okay, according to our trigonometric formula, u square, and this 2 sin theta cos theta can be written as sin 2 theta divided by g. So this is the horizontal range formula. You can write the reason here, since sin 2 theta is equal to 2 sin theta into cos theta. Got it? Okay. Condition for condition for the maximum horizontal range. So we know the horizontal range formula. Okay. So in that, if the angle of projection, okay, is 45 degree, projection is 45 degree, that means theta 45 degree, then in the formula, the sine 2 theta, that becomes sine 90, right? 2 into 45. So sine 90 it becomes, so sine 90 degree, it is 1. Therefore, the maximum horizontal range formula, or maximum, look at in the formula, u square sine 2 theta divided by g is there, right? Square sine 2 theta divided by g. So it becomes u square by g. So for the maximum range, sine 2 theta will become 1. You get the formula u square by g. Okay. Yeah. Let's see a problem based on this. Okay. A small problem. Yeah. This is the problem. A cricket ball is thrown at a speed of 28 meter per second in a direction 30 degree. Okay. It is throwing at 30 degree above the horizontal. Calculate the maximum height, time taken by the ball to return to the same level. That means the total time of flight we have to find, and horizontal distance. First, write what are the given things here. The given are initial velocity is given, right? So, what is the initial velocity? 28 meter per second. And the angle of projection is given, that is 30 degree. First, we have to find the maximum height. Find out that by using the formula. The maximum height u square sine square theta divided by 2g. So u value is 28 sine square theta. So it is sine 30 degree the square whole divided by 2g. The g value I'm taking 9.8. So solve for this. Can get 28 into 28, and this is 1 by 2. Sine 30 is 1 by 2, the whole square. Yeah, divided by how much it comes? 19.6. Solve for this. I get the h value near to 10 meter. So this is the maximum height traveled by the cricket ball. The second one, time of flight, total time taken to reach the same level. That is 2u sine theta divided by g. It is 2 into u. U is 28 into sine theta is sine 30 degree divided by 9.8. Okay, solve for this. After solving, you get 2.9 seconds. Next, to find out the maximum total distance, right? So horizontal distance traveled, it is u square sine 2 theta divided by g. So 28 into 28 into sine 2 theta. Sine 2 theta becomes sine 60 degree now. Theta is 30 divided by 9.8. Yeah, sine 60. The value for sine 60 is root 3 by 2. Okay. Solve it. 28 into 28 into root 3 by 2. 9.8 into 2. Therefore, horizontal range is 69.3 meter. Next one. Next problem. Yeah. This is the problem. Find the angle of projection for which the horizontal range and the maximum height are equal. Okay. So here the given is both are equal. So horizontal range is equal to the maximum height, horizontal range or the height is equal to this one. So the maximum height formula, we know that u square sine square theta divided by 2g, and this is u square sine 2 theta divided by g. So cancel the similar terms on the both side. U square and g will get cancelled. Therefore, sine square theta by 2 is equal to sine 2 theta. The sine 2 theta is 2 sine theta into cos theta. Okay. And 1 sine terms will be cancelled both the side. Therefore, you can write this as a sine theta divided by cos theta is equal to 4. 2 2's will be multiplied, or tan theta is equal to 4. Therefore, theta becomes tan inverse of 4. Okay. The value for tan inverse of 4 is 75 degree 58 minutes. Okay. This is the problem. We have to prove that maximum horizontal range is 4 times the maximum height attained by the projectile when fired at an inclination, so has to have a maximum horizontal range. Okay. So here, to get the horizontal range, the theta should be 45 degree. This all we know that. Okay. For theta is equal to 45 degree, the horizontal range is maximum. Therefore, R maximum is equal to U square by G. Maximum height attained is H maximum, right? So it is U square. If you take here the 45 degree for that in the maximum height formula divided by 2G. So U square sine square 45. Sine 45 is the 1 by root 2 whole square divided by 2G. Therefore, H maximum is equal to U square divided by 4G. Okay. So here U square by G is R maximum, right? U square by G, I can write it as a R maximum. So that divided by 4. Therefore, R maximum is equal to 4 into H maximum. So it is 4 times the maximum height. Yeah. So in today's class, we've studied all about the projectile motion, right? Trajectory of a projectile is parabola, and time of flight and maximum height and horizontal range. Formulas, how to derive, the method of deriving, and then condition for the maximum horizontal range, the formula, and we solve these numericals today. Okay, so the next class we are going to deal with the circular motion and centripetal acceleration concepts.